Let us solve the exercise number 8 in the part B of data structure lab. In this exercise, we are supposed to perform the operation on a graph of cities. And what they have said is there are two things that we are supposed to do. In the first part, we are supposed to create a graph of n cities using the adjacency matrix. And then we have to print all the nodes reachable from a given starting node in the diagraph using the breadth first search method. The first thing that you must notice over here is they said that you have to write a program, and it is not a menu driven program. So you must understand that this is not a menu driven program. So it is a straightforward program that we are supposed to write. So let's go ahead and let's solve this program. Now, before we venture into solving this program, let us first understand some basic requirement of adjacency matrix and the graph associated with it. I have here with me a graph which is a directed graph, and you are familiar that a directed graph has an arrow indicating from where it is starting and which is the source and which is the destination. So the arrow indicates the flow from the source towards the destination. What I have here is five vertices are there. These vertices are numbered from V0, V1, V2, V3, and V4. And how do we represent this particular graph in the adjacency matrix? Now, what we do is we write all the vertices along the rows as well as along the column. And if there is a path between the given vertex, that is between the two vertex, corresponding to that particular row, we represent 1. Otherwise, we represent 0. What do I mean by that is, so let's look at this particular vertex over this particular edge over here. And this edge is between the vertex V0 and V1. So there is an edge between V0 and V1. So we start from the along the row V0 and we go towards the different vertices from V0, which are the vertices that we can reach to. And we go from V0 to V1. So if you go from V0 to V1 over here, so you notice that this is V1 and this is V0. Whenever there is a edge between the two vertices, we represent that particular cell with 1. Suppose if there is no edge, if you notice over here, so there is no edge between V0 and V2, so there is no particular edge. There may be a path between them, but there is no direct edge. So when there is no direct edge, we represent it as 0. So from V0 to V2, there is no edge, so it is represented as 0. Similarly, from V0 to V3, even though there is a path, but there is no direct edge, we represent it as 0. Also, from V0 to V1, if you notice that there is already an edge that connects them, and we represent it as 1. Similarly, we take the other vertex, that is the vertex V1, and we try to find out which are the edges that are available there. Now, if you notice over here, from V1, obviously there is a path, there is a edge towards V2, and there is an edge towards V3. So if you look at here, so from V1, there is a edge which is indicated as 0. Also from V1 towards V3, that is this particular edge, is represented as 1. Okay. But you notice that there is one edge here between V0 and V1. But because it is a directed graph, you can only come from V0 towards V1. And there is this is like one way. You cannot go back from here. If there is a going back path, then that will be indicated with one more arrow. So this arrow is not there. So that is why you notice that from V0 to V1, the value that is shown over here is 0, indicating that there is no path between V1 and V0. However, there is a path between V0 and V1. So it is like you have a one way between V0 and V1. There is no return path. So from V0 to V1, there is a path, but from V1 to V0, there is no path. So if it was a non-directional graph, that is a graph without having any direction, in that case, definitely when you put 1 here, you are supposed to put 1 on the other side so that the symmetry along the diagonal is maintained. This is for a non-directional graph, not the graph that I am talking about. This is the diagraph, which is a directional graph. In this directional graph, that symmetry along the diagonal is not maintained. Now, let us come back to the story. Now, you know how this is represented, and definitely for all the other nodes also. So, for example, if I take the V4 over here, from V4, I cannot go back to V0 because this is not, this is a directional graph indicating from only from V0 you can come to V4. From V4, I can't reach anywhere. So, all the entries for V4 is 0. Similarly, all the entries you can come from V1 to V2, V1 to V3, but from here you can't go anywhere. So all the entries for V1 and V3 are 0. So this is how you represent the directional graph in the adjacency matrix. So we are supposed to create a matrix. Now, the next question that comes to our mind is how do we traverse this particular graph using the breadth first search? So, in the breadth first search, we know very well it is there are two versions. One is called as depth first node, that is DFS, that is depth first search. That means you are going in depth, you are going deeper, deeper, deeper into the graph. What is this breadth first, the search, BFS? We are going along the breadth. So that is the idea. So we span along the breadth of the graph and then we go next level and again we try to go along the breadth. So depth means you are going deeper into the graph. What is the meaning of saying deeper into the graph is suppose if you start from here, you go here, go here. If there is one more path, you go here, and then so on. You go depth wise. What about the breadth wise? Breadth wise is you complete this level. So this is one level. Let me read right. This is one level. This is the second level. This is the third level. So you complete all the nodes in this level first. Then you go to all the nodes in this level. Then you go to, suppose if there are many nodes are there, to simplify the graph, I have just taken only selected vertices. Suppose if you have many more vertices here, just assume that you have many vertices here. So you just complete all the vertices which are over here. So this is the breadth first search. You go along the breadth. Okay. Now, how do we solve this particular problem? Suppose say your starting point is V0. So what is the breadth first search for it? So as I've already told you, you go along the breadth. So how many which nodes are available here is only V0. V0 is available along here. So there are no other nodes are there. So this level we completed. Then we go to this next level. In the next level, we find out how many nodes are there. So in this case, we have two nodes here. So we make a note of that. So we say next we have V1 and next we have V4. So only two nodes are there. When this level is completed, we go to the next level. And in the next level, if there are, let's say, if you assume that there are many nodes are there, because of simplicity, I have not drawn them. So if there are there, we list them one after the other. So we list like V2 and V3 and so on and so forth. So we list all the nodes. So this is the base idea that we are using in the breadth first search. Now the question is, how do we achieve this thing in the data structure? We know that this graph is represented in the data structure using the matrix, which is called as the adjacency matrix. Okay, and this particular matrix indicates whenever there is a edge between the two nodes, this is indicated by 1. Okay, wherever there is a 1 indicates that there is an edge between the two vertices. This graph can be represented using the adjacency matrix. Now our next challenge is, so once this graph is represented, how do we traverse them in the breadth first search? So the idea of the breadth first search is, you are already familiar, you first select this node. That is the starting node. Remember, the starting node could be anything. So they may say that this is the starting node or this is the starting node, because in the question they said that from a given starting node. So the node can be anyone. So let's for the simplicity, I assume that this is the starting node. So you first take this node, you process this node. What is the meaning of saying process this node? So you start from this node V0 and you find out all the nodes which can be reachable from this particular node. So this is the starting point. From here, the next level is which are the nodes that are directly reachable from this node. Now you may have one more, you may have one more. Remember, don't be carried away by the length of this particular edge. So you may have V of 5 here. Okay. Now this is also in the same level. So this is directly connected, even though if you draw the levels over here, you may say that this is in the other level. No, it is not in this level. It is in the this level, this particular area. This is in this area. Why this is in this area? Because there is a direct connection between the V0 and V5. So this is a direct connection. So first thing is we take this node and we find out all the vertices which are directly connected. That means there is an edge between this V0 and all the others. So you may have in my graph that I've shown over here, I have only two nodes, but I can have more than that. So you store them here. So this V4. So we started with the V0. That is the starting point. This starting point is given to us. So we store V0, then we store V1 and V4. So this level is complete. If you have no other connection between the V0, then go to the next level. So in the next level, this is a, so in order to reach here, in order to reach V2, we have a path from V0 to V1, then V1 to V2. So this is the second level. So this is the first level from here to here. This is the second level that you have here. So which are the nodes that are reachable from now, not from V0, from this level. So from this level. So from this level, there are two nodes are there. So take the first vertex and then find out which are the vertices that are reachable, or which vertices have the edge between V1 and the other one. So V1 and V2, there is an edge, you represent them. V1 and V3, there is a edge, you represent them. Between V4, there is no edge there, so you don't put anything. So this level is complete. Now come to this level. So you have completed the first level. This is over. You have completed this level. Now come to this level from V2. If there is any connection, you add them here. So you add them here. If there is one more connection, you add them here. So what is this that you are representing? This you know very well. This is an array. So this is an array. So you put them into an array. However, this is a special type of array. So can you guess what is this particular array? So this is a queue. Okay. So what we are doing is, when somebody says that start from here, you take that node, you you enqueue it into the queue. So in your stack, we say you push it into the stack. In queue, you say you enqueue it into the queue. Okay. So when somebody says v0 is the starting point, you just enqueue it into the queue. So it is done. Now, what is the next thing that you do? So you look at the queue. There is one v0. Assume that these are not there. Okay. So you have v0 here. You dequeue them. You pull this v0 out. From this v0, you find out how many nodes are reachable, or how many vertices are reachable. So which are the vertices? So you can reach from v0, you can reach v1, and you can reach v4. So what you do is, remember, this is taken out. This is taken out. Now this is not there. I've taken it out. So now you enqueue v1 and v4. Just assume that this is not there. Okay, so you enqueue them. No more edges are there. So you stop here. Now again come back to the queue. So from the queue, you remove the frontmost element. Remember, this is already taken out. You remove the frontmost element, that is v1. You remove this element. So this is pulled out now from the, it is dequeued from the queue. So from this v1, you find out which are the vertices that are reachable, or which vertices has the edge. How do I find that thing? You know very well. So from v1, you go to the adjacency matrix, and in the adjacency matrix, if you find a 1 there, okay, that means for the corresponding vertex there is a edge. So this is how we find out, even though in the drawing it is easier to figure out that so there is an edge, but in terms of adjacency matrix, you have to find whichever cell that has 1, those two corresponding edges, those two corresponding vertices have the edge. So v1 and v2 have an edge here. Similarly, v1 and v3 has a edge here. So you find out how many edges are there for this v1. So you, whichever is the vertex, that you push it into the queue, or we don't say push, but we use the word enqueue. You enqueue it into the queue. Similarly, v3, you enqueue it into the queue. Okay, so this is over. You have popped out, or you say dequeued from the queue. This is dequeued from the queue. So this front is here now. You dequeue v4 and find out from v4 how many edges are there. You know very well, for v4 there are no edges are there, because all are 0. So you don't push anything there. So now my v1 is over, v0 over, v2 over, v4 over. Now this is v2. You dequeue this v2 and find out how many edges are possible. So if you look at here v2, you notice that all are 0. So that means to say that there are no edges are there. You don't push them into the stack. Similarly, the dequeue the last element. Remember, this is over, this is over, this is over, this is over. Now last one, v3, you dequeue it and you find out whether any nodes are reachable. If no nodes are or no vertices are reachable. That means there is no edge. You don't push anything into the stack. So this is the idea that we follow. However, there is a small thing that you have to notice. So what is this small problem that you may encounter? Now I'm giving you a very different graph here. Now if you look at this particular graph, and if somebody says that, see, this graph again is represented using the adjacency matrix. And if you look at V2 for that matter, if you just take V2 here, how many edges are there? So from V2, find out how many of them are 1. So V2 to V0, there is a edge. V2 to V0, there is a edge. You notice that. V2 to V3, there is a edge. V2 to V3, there is a edge. V2 go along here. V2 to V4, there is a edge. So when you look at the adjacency matrix, you know that there is a edge there. Now, suppose somebody says that this is a starting point. From here, you tell me you perform the breadth first search. So what is the first thing that you do? You take a queue. You take a queue. And inside this queue, first put V2. You put V2. So this is called as enqueue it. Then immediately dequeue it. Remove this from the queue. So this is the front of the queue. You know very well. You pop the element or you dequeue it from the front, you enqueue it from the rear. So you have two pointers there. For any queue, you have two pointers. Which are the two pointers? You have the front pointer, wherein you add, when you remove the element. You have the rear pointer, wherein you add the element. So from the front, you pull out one element, that is V2. Then from V2, you find out how many nodes are reachable. Remember, I can use the adjacency matrix and find out how many of them are 1 here. All those places where 1 is there, that is V0, V3, and V4, I push them into the queue here. So I'm going to push V0 because there is a edge here. Then I'm going to push V3 because there is a edge here. What is that? And I'm going to push V4 because there is a edge here. Okay, that is done. Okay. Now I'm going to take the V0. Okay, so I take V0. From V0, so I'm going to remember the front was here. Then you move the front to the next location. They remember rear is here now. So rear is the last point. Okay, front is the front point. You know how the queue is working. Okay. So you find out from the V0, you just look at the V0 and you notice that V0, all of them are 0 here. So all of them are 0. That means from V0, you are not going anywhere. So nothing is possible. So you remove this V0. Now come to the V2. Okay. So V3. Now from V3, how many nodes are there? So from V3, you notice that there is 1 here. And which is this one? V0. So will you push this V0 here? The answer is not. Why? Because we have already considered this V0 here. So we already have taken V0 here. So again, if you put it, this is not going to work out. So you have already visited V0 here itself, right at the beginning. So we will not reconsider that. So that is one extra thing that you must make a note of. So if you visit a node once, you are not going to visit it again. So what do I mean by saying that is this V0 was visited via V2. Again, from V3, we won't visit it again because we have already checked whether there is any nodes or not. Similarly, from V1, we will not again reconsider V0. So in other words, we visit the node only once. We won't visit it many times. So that is the idea you must understand. You must keep it in mind. So let us now come back and let us see the logic here. So for a given matrix, we represent the adjacency for a given graph. We represents the adjacency matrix, and then we create a queue. Okay, when somebody says that my starting point is V3, you and queue them into the queue and dequeue it immediately. And first thing you must mark is you have when you dequeue it, you mark it and say that I have visited that particular vertex. So you have one more array. You need to create one more array here called as visited array. Let me call it as V. And you say that V3 is visited because you are going to find out how many nodes are possible from V3. So from V3, you can go to V0 and nothing else. So done. Okay. So what is the next thing? So you pop up this one or you dequeue them. Then you take this node V0. So from V0, you find out how many nodes are possible. Okay. And after that, you mark it as visited. So you say that this V0 is visited. Now let me take this example over here, and this will be the last one. Then we will start writing the code over here. So we are representing them with the adjacency matrix. You know very well in the adjacency matrix, whenever you have one, it indicates that we have an edge between the two vertices, that is V0 and V1. So V0 and V1, you have an edge. Now let's assume that this is the starting point. V0 is the starting point. So apart from this adjacency matrix, you have to maintain two things. One is this Q. So you take this V0, you push or you say NQ it into this Q. Let me call this as one as Q, where you push it into the Q, and then you pop this one out or you dequeue it from the queue, and then you find out how many nodes are possible directly, how many edges are there. So from V0, if you look at here, there is only one edge, and that is for V1. So you NQ V1 into the queue. That is not the end of it. You take one more array called as visited array. Okay, and in this visited array, you store V0, saying that I have visited the V0. So V0 is over. Now remove this element. Remember, this is the front of the queue and this is the rear of the queue. You know very well. I won't talk about the queue again, otherwise it will become a 4 hours one video. So this is the front of the queue. You take the element from the front of the queue and V1 is taken out. From V1, so this is V1. There is only one edge here, and that one edge is for V2. So you NQ V2 into this list. Remember, this is taken out. This is taken out. This is taken out. So V2 is the actually the front now. Now you push this or you NQ it into the queue. Okay. And what is the next thing that you're going to do? You mark this one as visited. So you mark here as visited. Okay. Now go to the next one. You dequeue it from the queue V2. So you take this V2, and from the V2 you find out how many nodes are there, and you notice that there is only one edge which is connecting V3. So there is only one edge that is connecting V3. So you NQ it into the queue. Okay, so this has been taken out now. This is taken, V2 is taken out, V3 is there in the queue. Remember, there is don't expect me to say that there is a front and there is a rear a pointer for the queue. Those pointers will be there, front and rear pointers will be there. That is a queue, and you know very well in the queue those two pointers will be there. So you take V2, you have processed V2, you mark them as this V2 is already over, you have processed it. So now you pop this out, or you dequeue it from the queue. So you take this V3, and from the V3, you know that there is one edge here, that is V1. So will you push it into the queue? The answer is you won't push it into the queue. Before you push it into the queue, you just find out whether it is already there in the visited list. So if it is already there in the visited list, so you notice that V1 is already there in the visited list, we will not push them into the queue. So what are the things that you must do? First thing is, when somebody says this is the starting point, you push it into the queue. Okay, you pop it out and then say that you have visited it, and also mark it as visited. Then you find out all the edges that are reachable from this node. Okay, and if there is any edge that is possible between this given node and the any other vertex, before you push it into the queue, you first find out whether that thing is there in the visited array. If that node is there in the visited array, that means you have already visited it. You won't visit it again. So this is one extra step. So before you push it into the queue, you have to find out whether that particular node, whichever is the node or vertex, whatever you call it as, whether that node is there in the visited list. If it is there in the visited list, you don't touch that. Okay? If it is not there in this list, then you say that that particular node is can be processed. Otherwise, if it is there visited, that means it is already processed. Now, how do I say that a given vertex V0 is visited, V1, this node is visited, V2 is visited? So, you know, in the array, if it is 0, that means you are not visited. If it is 1, that means you are visited. If it is 0, means it is not visited. So, we just use this zeros and 1 to say that whether we have visited the particular node or not. So what we do is, initially we take this visited array. This is an array which contains how many cells. So we say V0, we can write a V0. So we say V0, you know, array index starts from 0 in C. Okay, then array index starts from 1 and so on. So this is 1, 2, 3 and so on. So initialize the visited array as all zeros. So why do we initialize with a 0? To say that none of the nodes are visited. So initially no nodes are visited. The minute you take one of the node and process it, you change the status and make it as 1. So when you process it, you make the status as 1. So we initialize, in other words, we initialize the visited array as 0. And then whenever we process one node at a time, we change this initial value from 0 to 1, indicating that that particular node is visited. So how do I say that there is an edge between this node and this node? I find out whether that cell has 1 here. Similarly, how do I say that I have visited the vertex 2 or not? How do I say that? I go to this visited array, and if the value is 1 for this vertex 2, that is this vertex, if this value is 1, that means I have visited. For this vertex V3, the value is 0, indicating that I have not visited. So in the visited array, for the corresponding vertex, if the value is 0, you have not visited. If the value is 1, that means you have visited. Remember, you only take those nodes which are not visited. So if you already visited a particular node, you don't go and take the value again and again. So these are all the stories that we have talked about. Let's go ahead and let's write the code now. I'm going to go to the code block here. I will click on this file and I'm going to say new file. I will take C++ as my code. Let me click on OK. Let me click next and next, and I'm going to go to my folder where I have stored all my programs, and I'm going to say BFS, that is to say that breadth-first search. And let me quickly finish it off. Let me just slightly zoom in for you. So as usual, you are going to say include stdio.th. Okay, and we need a few global variables over here. What are the global variables that are required? First of all, we require a queue. So I'm going to say int queue of 5 cross 5. What is the meaning of saying 5 cross 5? Maximum we will take only 5 vertices. So how many vertices are there here? 1, 2, 3, 4, 5. Okay, during the examination, I don't think so you will go beyond 5. So I will restrict it to 5. Suppose if you are a person who can type very fast, then make it as 10. 10 cross 10. Remember, it must be a square matrix, but I feel let it be 5. Yeah, a smaller one. That part is there. Then we need one more thing. This is the queue story is over. Sorry, this is not a queue. This is the adjacency matrix A. Okay, this is the adjacency matrix. I'm representing this one, adjacency matrix. So I'll call it as A, adjacency matrix. Then I need a queue. Okay, how many nodes will be there in the queue? Naturally, how many vertices will be there? Those many values will be there in the queue. So I'm going to take the queue here. Again, the value is 5 because my adjacency matrix has 5 vertex. Naturally, it must be 5. Then I have this visited node. Again, this is 5. So how many vertex you can visit? Naturally, if there are 5 vertices are there, you can visit only 5. You cannot go beyond that. Okay, this is obvious story. Okay, done. Okay, and we need one extra thing. What they have said is you will be given a starting node. So I will take a word called as a start, indicating the starting node. So they will say start from here, or they may say start from here, or for this they may say start from here. So this is the starting point. So they will give me the starting vertex. So I'll call it as starting vertex. And because it is a queue, you know very well, queue has the front, and front is initialized as -1. Queue has a rear. Uh, let me, should I write it as, otherwise you'll get confused. Okay. Let me write a front. Remember, front is for, what is this? Queue, and rear is also -1. You know very well, the queue is initialized with front equal to -1 and rear equal to -1. That means if the front is -1 and rear is -1, queue is empty. You are already familiar with the story of a queue. Otherwise, you just go and refresh your knowledge on queue. I won't talk about the queue in depth. Let's go in particular in this exercise, definitely. So let's start with the main. So I have this main here. And you know very well, whenever you have a matrix like this, if you have a matrix like this, you need two variables, I and j. You are already familiar. You are whenever you are using the matrix, you use two variable, that is int I comma j. So these are this is required. Okay. So now let us start with that. So they said that you create a graph of n cities. So we have to get what is the total, what is this n. Remember, in our case, the maximum n is 5 because our array itself is restricted to 5. So don't put 10 cities because your matrix itself is 5 cross 5. So you cannot go beyond that. Let us use a printf statement. And let us ask the user, enter the number of cities, okay. What is this cities you said? So from where did you got this cities? The cities is, they said that this is a graph of cities. Okay, so then why didn't I talked about the city? See, whether it is a city, whether it is a product, whether it is a person, it doesn't matter for me. What matters to me is this is a vertex. Okay, so this is the vertex, but you call it that vertex as cities, you call it as countries, you call it as state, that is up to you. So, but for mathematics, that is a vertex. Okay, but then why didn't I use the word vertex? Because it is not given in the question. They didn't said anything. They said that it is a cities, so I'm going to ask it as cities. So simple as that. What they have asked, I'm doing that. Okay, let's use a scanf statement. Percentage D, and we need the n here. So I just forgot this n. Let me put that n here. Sorry, I forgot that n altogether. So where should I put it? Should I put it here or there? I will put it in the beginning. Okay, n cities. So what is this n? Now you may ask this question. They said of n cities. Okay, so you need to read that n. Okay. So you got this n here. So I have added one extra variable here, and that is n. So this n is total number of cities. That being done, now we will create the adjacency matrix. So what is the first thing that they said is create a graph using adjacency matrix. So we will ask the user to enter the adjacency matrix. So I'm going to say printf, and I'm going to say enter the adjacency matrix. If you have a lot of time, you can say adjacency matrix for the given city. You can write that, but I'm not going to write it. You know very well during the examination you don't do something which is not absolutely required. So you just put it like this. As usual, you need a for loop to read something into the vertex here. I mean something into the matrix here. You need two counter variables. So I'm going to start with for I is equal to 0, I less than n, I plus plus. So this is done. And what is the next thing? Some student, what I have noticed is you again write the same thing. Please do not type it again and again. The reason is there is something called as artificial intelligence, which will write the program and give it to you. If you want to get a job in the computer science, you use copy paste. Whether you like it or not, you use copy paste option and speed up your typing, which will help you even during your examination. And that you are going to practice it during your practical, not during the examination. I have found many students, they start copy pasting just during the examination. You will make blunders. So when you are writing the code, make a copy paste of it. Now what is the easiest way to repeat this line? Okay, so you press Control D. So what did I do here? I pressed CTRL plus D. It will repeat this line. So if I keep my cursor here and if I press Control D, it will repeat this line. Control Z, it will undo it. Now remember, after this, you just change it to J, you change it to J, you change it to J. It done. Now write the scanf statement, and percentage D, you're going to read the element into the matrix there. So I comma j is read, done. Okay. Now next question that you're going to ask the user is which is the starting point. So from the given starting node. So how do I do it? I'm not going to write it. I'm going to copy this. I need a printf statement. I need a scanf statement. I use Control C and Control V here. It done. So what I'm going to say, enter the starting vertex, or I'm going to say starting city, because it is this story is about a city. I'm going to say starting city, and I'm going to read the start, not this one. Where is the start? I've already taken this start. Okay, right at the beginning I've taken this start, so I'm reading that start. Done. What's the first thing that you are going to do is, before you do anything, you have to go here and you have to make this visited array all the elements as 0, because you are not visiting, you have not visited any of them, you are just starting, so all of them are 0. As you visit, you make that as a 1. Okay, so that is this is called as initialization. So let us initialize this one. I need a for loop, so I'm going to just copy Control C, and I'm going to use Control V to paste it. And then I'm going to say my visited, so that is V, visited is V. So visited of I equal to 0. So done. Okay. Now I have to perform the breadth first search. Assume that I'm going to write a function for breadth first search, and I will give the starting point for that particular thing. I have not written this function, so just assume that I have written this function BFS, which is yet to be written, but I'm going to call that function. So let's go and write the BFS now. So we will write it outside the main. Don't write the function inside the main. You can't write one function inside the other. So this BFS, if you notice there, it is not returning anything. So we say void BFS breadth first search. So this is breadth first search. You give the starting vertex. So what is this starting vertex? You say which is the starting vertex from here you have to start. So I'm going to take let's go here. I'm going to take the starting vertex and I'm going to say int v. Remember, it is a vertex for me. It is it may be a city, it may be a country, it may be something for somebody else, for a mathematics person or for a computer science student. It is just a vertex. So I'll take it as a v. What's the first thing that we do is we go to the visited. Our visited matrix was there visited. So if you say v0 is the starting point, you mark it and say that you have visited. So you just mark it and say that you have visited it. So you say visited of v. So this is very confusing, is it not? So should I change this as a, so what should I say? Yes, I'll take it as yes. Visited of starting yes is equal to, and I otherwise you will get confused, which is v, this v, that v. So I've just taken it as yes, starting point, yes, so simple as that. Okay, yes. So if can you write a start, you can write a start. If you are very good in typing lengthy words and you have studied you during the holidays you went and studied typing, you type the start, this, that, and so on. I use the single letter there because I need the speed during the examination. Okay. So you say visited of starting is 1. Okay, and we need a few things first. So what is the first thing that you do? So from this queue, you take one element. So from the queue, you take one element. So that you can take it as the current element. So the element which is getting processed. Suppose if you are processing this element, you say this is the current vertex, okay, in which you are working. So that is the idea. And as usual, whenever we talk about the arrays and other things, we need a counter variable. So how we have used ing for our counter variables, we are going to use a counter variable I, and I'm going to use one more called as current. Current is the one that I am currently processing, that obvious one, current node. So that is the meaning. CUR I have written. You can write C, but just otherwise it will be too confusing for everybody. Okay. So what's the next thing? So you take this one. Okay. And what is the next thing? What's the first thing that you do? So when somebody says you, what is it? Start from here. What's the first thing? You push it into the queue, or you say enqueue it into the queue. So you just enqueue it into the queue. So you say queue of. How do you add in the queue? You add it at the end. So this is rear. So plus rear. You know this is queue. I won't talk anything about the queue. So that is the starting point. So that's it. Okay. So you add the starting vertex. If somebody says this is a starting vertex, you add that starting vertex into the queue. Also, you pop this one and you say you have visited. You have visited that I have already written. Visited is true. So I was with overexcited, so I wrote that visited equal to 1 right at the beginning. Okay, now let us write the all the one. So you have if somebody says you start from here, you push it into the, or you enqueue it into the queue, and you dequeue it, and then your breadth first search will start from here. Okay, so let us write the story now, printf, and we are going to say what we can say. We can say, okay, BFS from the city, okay, from the, remember, even though again don't get confused, what is this city, sir? You are in between, you are introducing one new things. Don't say that, even though it is a vertex for me, but according to the question, this is a city. Okay, so what to do? Okay, so that is why I'm using, they said it is city, so I'm using that word city. Okay, don't get confused. Okay, so is, okay, and remember, when the first thing is, it's not something that is not required. Okay, the first thing is you, somebody says you start from here, that node is the starting node. V2 is the starting node. From V2 you may go to V0, you may go to V2, V3, V4, and so on and so forth. You can go there. That is the starting node. There is I'm not going to search whether it is possible or not, so I'm going to just print that one. So what is this? I will tell you. Okay, just give me a second. I will complete this story. Otherwise, I may miss out something. So this generally happens. So what did I wrote here is, suppose if somebody says the, this is the starting city. Now I'm using the word city because in the question they said it is a city. So this is the starting city, city number 2. So from the city number 2, this is the starting point. So this is the starting point. Yes, this is the starting point, city number 2. So what is, how is it going to come? You are going to say BFS, that is breadth first for search, from the city number 2 is 2 and something else. 2, 3, 1, 0. You may get all the other numbers. You may get many other numbers. So starting from the city 2, okay, is first city is, if you are starting from the city 2, first city that you have visited is city 2 itself. Then you may visit a city 0, then you may visit a city 3, then you may visit city 4. So what I am writing is, starting from the city 2, first node encounter or the first city encountered is city number 2. Then you may say city number 0, city number 1, city number 2, city 2 is already there, city number 3, and so on and so forth. So it is depends on the graph that you have drawn. Okay. Now, how do we go about doing it? See, remember, you take one city, you push them into, or push, or enqueue it into the queue. This is word they have used, a very lengthy tongue twisting word. Enqueue into the queue, and then you enqueue some other vertices, and some other vertices, and so on, from queue, this one, and so on. Then you dequeue it, okay, and then find out whether you can reach something else, and so on. So when will you start? So you start with an empty queue. So the story is, initially you started with an empty queue. How do I say the queue was empty? Because I said front is equal to -1, rear equal to -1. So this is the queue. So queue with front equal to -1, rear equal to -1 is empty queue. Then you keep on adding elements into the queue. Okay? And when will you stop? So you know very well, adding is done at the rear side, removing is done at the front side. You know this story. Okay, so as you remove one element, this front will go here. The next element, if you remove the front, will go here. Next element, if you remove the front, will go here, and this story will continue, and until the front comes and meets the rear. When the front comes and meets the rear, you say the queue is all over. There is nothing left in the queue. Queue is completely empty. So you will have to keep on doing it until this front becomes equal to the rear. So when the front becomes equal to the rear, you just stop it. So this is what we are going to do. So we are going to write that story here now. So where is it? So as long as the, what is this, while, where is its while go? So as long as front is not equal to rear. Okay, so you write this story. So what is the thing? You take the current node. What is the current node? Current node is the one that is popped out of the queue. So you suppose if you say V2, you pop this out or dequeue it out. That one is the current node. So V2 is my current node. From V2, you find out how many nodes are reachable. So this current node is this one. The currently I'm processing. So I'm going to say current node is you remove one element from the queue. How do you remove one element from the queue? You say plus plus front. You know very well this story. Please, if you don't know, watch the programs on the queue. I won't talk about this. This is the dequeuing one element from the queue. I won't exclusively say that thing. Now, once you get the current node, from the current node, find out how many nodes are possible to visit. So how many nodes you can visit? How many nodes you can visit? How do I do that? You check whether from V2, so from V2, can you reach V0? Can you reach V1? Can you reach V3? Can you reach V4? So you do that thing. So I need a for loop here. So I'm going to start with the for. So do I have the for loop here? Now actually I have the for loop here. You can copy this one, Control C and Control V here. Okay, I have the for loop here, and I'm going to just put a flower bracket here. Now, what is the condition? The condition is you visit it only if it is not visited. If it is already visited, you don't visit it. And when will you consider the node? If there is this value between V0 with the current node, if we take this is the current node, and the V0, the first node, if it is 1, that means there is an edge. If it is 0, there is no edge. So we are going to do use that trick here. So what we are going to say? So we are going to say if, okay, I will use a slightly longer here. I'm going to use one more bracket here. A of a current. So what is this? The current node. So remember, in our case, V2 is the current node. If you say starting point, V2 is the current node. So from V2, okay, from the current node, if there is a edge, how do you say there is edge? This value must be 1. So for this vertex 0, if there is a value is 1, then you consider it. So how do I say that? From the current node, okay, of I, so remember this one. So this is the current node. Current node is this one of I is 0. So initial, you know very well, I is 0. Initial value of I is 0. So what will be the value? So this is the current node. Current node I is equal to 0, I is equal to 1, I equal to 2, 3, 4, and so on. So current node of I, this one, I is 0. If it is 1, okay, so that is what I'm checking. The current node of I, if it is equal to 1, that is not the end of it. And what is the next one? Remember, you will consider a node only if it is not visited. So that's very, very important. So you will consider the node only if it is not visited. So you are going to say, what is the next one? And visited, V is my, you notice I have initialized all of them as 0. So V of I, if it is equal to 0. So initialized, remember we made all the visited as zeros. So this is all of them are zeros. So initially you don't visit anything. Okay. If you have already visited it, don't take them into consideration. So if this is the case, okay, remember I'm going to just put it here so that it is easier for you to see what you are going to do. So from V2, you find that there is a edge for V0. Okay? And if it is not visited, then you put it into the queue. So you put that into the queue. So you push it into the queue, or you enqueue into the queue. How do I say you enqueue into the queue? You say go to this queue, and you know very well adding is done at the rear part of the queue. Okay, so you know very well. So you put this vertex into the vertex number I, whichever is the I value, you know very well, I is from 0, 1, 2, and so on, it will go. That I value, you put it into that queue. Okay, and very, very important one, you say that you have visited that particular, so that you don't consider it again. So visited of I, you touched that one. So visited of I is equal to 1. And then, because you visited it, you just have to make a note of it, and you have to tell them that, okay, I have reached I. So you have reached I. So remember, I'm putting some space here. I'm putting some space here. Also, I will put some space here. So some student don't put space here. Let me take the cursor somewhere else. I put a space here. Okay, you notice that there is a space here, and there is a space in the beginning and at the end of this. Okay. However, what I noticed is some students are there, after telling them 101 time, they put the space in the scanf. Don't ever do that. In the scanf, don't put the spaces. In the printf, you put the spaces to make it appear properly. Okay, which one I'm going to print is, I'm going to print this I. So as simple as that. Yeah, that's all you need to do. You don't need to do anything else. The rest of them during the iteration. So I value will start from I equal to 0 up to n. So you start from the I equal to 0. You start from here, I equal to 0. If there is a vertex, you push it. Then if there is no edge, you don't push it. If there is no edge, you don't push it. If there is an edge, you push it and mark it as visited. If there is an edge, you push it and mark it as visited. So simple as that. Okay. So let's go ahead and let's see whether we have done any mistake, and let us keep our finger crossed and let us give it a try. Assume that I have done the required story. Okay, so let's remove some extra spaces if it is there. Okay, done. Let me save it and let me give it a try and see whether something is missing. So definitely one semicolon is missing. Okay, done. And there is one more semicolon that is missing. Save it and give it a try. And so what is this has come? I don't know how it got connected to the internet. I am very surprised I am not connected to the internet. Okay. Anyhow, let me not bother about that. Okay. So enter the cities. You have the enter the cities. I'm going to use this as my starting point, and I'm going to try this one. Okay. So enter the number of cities is what is this? 5. I'm going to put this 5. You have to put this adjacency matrix. So let's start with the all the zeros, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. That is done. Press enter. Okay. Then 1, 2, 3, 4. Last one is 1. So look at here. I'm writing this one. Okay. Last one is 1. Done. Then 1, 0, 0, 1, 1. Done. 1, 0, 0, 0, 0, done. 0, 0, 0, 0, 0, done. So we have done all the vertex. Remember, the value is 5 means if you are starting from 0, it is only up to 4. Okay, done. Okay, press enter. Done. Okay, starting node I will take a V2. Starting from the node 2, I'm going to take it. Press enter. And what are the nodes that are reachable from the V2? So which nodes are reachable from V2? You can reach which one? V0, V3, and V4. Okay, so these are reachable. Okay, so from the city 2, you can reach city 2 itself. See, some people, I don't know whether which one is correct or not. I'm a bit confused about it. Some people will say that from 2 you can't reach 2. Some people say, and that is actually valid. Okay, the reason is, if you say from 2 if you can reach 2, then if you look at here, from 2 to 2 this value must be 1. Okay, but then why you are showing this 2, sir? This is the starting point. You said you are starting from here, so you have visited this. Okay, then you may say, hey, why you are putting this, sir? So this is correct. No, sir, you say from V2 or to V2 there must be 1, because there must be an edge. No, sir, it is a correct. There must be an edge like this, starting from V2 to V2, one edge like this. So your math teacher might have shown you like this, one edge, self edge. It is not there, sir. Then why you are showing 2? The reason is you said you start from city 2. That means you have visited 2. Okay, so your city 2 is already visited, so that's why I'm using that. So don't get confused. So this is the story. Now let me go with this story, because it can reach many things. So I'm not wasting your time. So this program is over, but I'm just cross validating whether it is possible to do this one or not. So let's start with them. We'll just put it here. So number of cities, if you are not able to see, number of cities is 5. You press enter, and I'm going to enter this adjacency matrix. If it is not showing, please zoom out. I'm going to put this value there, so that is a space separated. So 0, 1, 0, 0, 1. Okay, then 0, 0, 1, 1, 0. Done. Then all 0, 0, 0, 0, 0, 0. Done. Then again 0, 0, 0, 0, 0. Done. 0, 0, 0, 0, 0. Done. Press enter. I'm going to start from the vertex 0, the city number 0. I'm going to start with the vertex 0. Which are the cities that are reachable? Now, if you look at this graph, from this V0, you can reach all of them. V1 and V4, you can reach. This is one level. Okay. Next level is V2 and V3. Okay. If you had many other, you would have reached them. So this is the what you're supposed to do it. That's all in this exercise. Thank you for your interest. We will meet again in the other exercise. Thank you.